Let's talk about Newton's second law. So Newton's second law is the law with the big equation. So you've probably seen this equation before, F is equal to ma. Now in this equation, F is the net force on the object, and that is measured in newtons. Now I will talk a little bit more about what the term net force means later, but for now, just know that F is force. M is the mass of the object, and we measure this in kilograms. So when you're doing these problems, you want to make sure that your mass is in kilograms. I know that in the United States, we like to weigh things in pounds. Now, weight and mass are actually different things, and I will talk about that later. But remember, your mass, you want it to be in kilograms. And then A, of course, is the acceleration of the object. You guys have already learned about acceleration. It's a change in velocity, and that is measured in meters per second squared. Now, a better way to examine this equation is if we divide both sides of that equation by mass so that it looks like this. A is equal to force divided by mass. Now, this is actually the way that Newton originally wrote this equation, but of course F equals ma looks just way prettier, so we just learn it that way. But this is a better way to examine this equation because we can really see what's happening to acceleration when we have a certain force or a certain mass. So when forces are unbalanced, then we will have an acceleration. Okay, remember Newton's first law says that if forces are not balanced, then we have no acceleration. But if we do have unbalanced forces, there will be an acceleration. Now, this acceleration will depend directly upon the net force. See how acceleration depends directly on force because force is on the numerator of this equation. When force increases, acceleration increases. And the acceleration depends inversely upon the object's mass. The mass here is on the denominator, which means that when the mass increases, the acceleration will decrease. And if you think about that, it makes sense, right? If you have a bigger force, then you'll have a bigger acceleration. If you have a smaller force, you'll have a smaller acceleration. If you have a large mass, it will be hard to accelerate, so you'll have a smaller acceleration. If you have a small mass, it will be easy to accelerate, so you'll have a larger acceleration. So let's do a couple examples with this big equation. Now we have a 3,000 kilogram plane has to accelerate at 12 meters per second squared in order to take off. What force do the engines have to give the plane in order to accomplish this? Now, when you guys are doing these physics problems, I would like you to write down your givens, write down your equation, and then plug in your numbers and solve for your answer. So what I mean by this is, number one, let's write down our givens. So we have a 3,000 kilogram plane. We know that that is a mass, so our mass will be 3,000 kilograms. We know that this plane has to accelerate at 12 meters per second squared in order to take off, so our acceleration is 12 meters per second squared. And then we want to know what the force is that the engines have to give the plane. So our force equals question mark, because that's what we're solving for. Now you'll see that when I do these problems, I like to write F equals question mark. So I like to write whatever I'm solving for, I like to write a question mark next to that. Now we write down our equation, force is equal to mass times acceleration, and then this is easy peasy, we could just plug in our numbers here. Force is equal to mass, which is 3,000 kilograms, times acceleration, which is 12 meters per second squared. We plug this into our calculator and we get that the force is 36,000 newtons. So that is our force. We box our answer. Do not forget to put your units. Now, that was kind of an easy problem, right? We just had one force and that's causing an acceleration on a certain mass. Now, sometimes we don't just have one force. So when I gave you that big equation and I said that F stands for the net force, net means the sum of all forces on an object. So the symbol for this, you'll see sometimes F sub net or the sigma F. Now, sigma, you might have seen this symbol in your math class before. It just means the sum. So basically we're saying, okay, the net force is the sum of the forces in a certain direction. So we take the horizontal, the X direction, separate from the vertical, the Y direction in these calculations. So net is like the total force on the object. If I asked you what the net force on an object below these objects I'm going to show you below, what would you say? So if I had a 5 Newton force to the right and another 5 Newton force to the right, what would the total force be on that object? Well, they're both to the right, so you would say you just add them together, right? So you would get 10 newtons to the right. If I had a 5 Newton force to the right and a 3 Newton force to the left, what would that net force be? Well, the 3 Newton force is to the left, so we would have to kind of subtract that force from the 5 Newton force. So it would be 5 newtons minus 3 newtons, and that would be 2 newtons to the right. And then last but not least, if we had a 5 Newton force to the right and a 5 Newton force to the left, well, those forces kind of cancel out, right? So our net force would be 0. Now, another way to say this is that, okay, you denote a certain direction to be the positive direction. Usually we say the right. So it would be 5 newtons minus the 5 newtons that are in the left-hand direction, which is our negative direction. So 5 minus 5 is 0. Okay, so this is how we find the net force on the object. So let me show you a couple other examples. So my equation is already there. Oops. So example number 2 is if you push a 2-kilogram chair across a frictionless floor with a force of 5 newtons, what is the acceleration? Now, if it's frictionless, that means we don't have any friction. Okay, so our givens here are going to be the mass of the chair is 2 kilograms. The force applied, that's what that sub A means. We're applying a force of 5 newtons to the chair. That's 5 newtons. And then we want to know what the acceleration is. So acceleration equals question mark. Now, if I draw a picture of this chair, I have my chair. Here's my applied force of 5 newtons. Now, if I'm looking at my equation, the net force is equal to mass times acceleration. The only force that's acting in the direction of this acceleration is that 5 newtons. So that's what my net force is going to be. I know that my mass of the chair is 2 kilograms, and I know that I'm solving for acceleration. Now, sometimes I will tell you guys to actually solve this equation for the thing that you're finding. So if you did that, you would just divide both sides by mass, and we would just get the net force divided by the mass is equal to the acceleration. And plugging in our numbers here, I know net force is 5 newtons, mass is 2 kilograms, so we get 5 newtons divided by 2 kilograms for that acceleration, and we end up getting 2.5 meters per second squared for our answer. Now, what if we took this same problem, but instead we now added friction? So if we now push the same 2-kilogram chair across the floor with a force of 5 newtons, but there is a friction force of 3 newtons present, what is the acceleration? So again, let's write down our givens. I have the same mass of the chair as 2 kilograms. My applied force is 5 newtons, and now I have a friction force of 3 newtons that's opposing the motion of the chair. And again, we want to know what the acceleration is. So here's my chair. Here's my applied force of 5 newtons. Now, what direction is the friction force? Remember, friction force opposes the motion of the object. So if my motion is going to be to the right, the friction force is to the left, and that's going to be 3 newtons. So again, here's my equation. Net force is equal to mass times acceleration. Now this is a little bit more complicated because my net force is not just going to be that 5 Newton applied force. I now have a friction force that's opposing the motion. So if I'm going to find my net force on the object, I have to denote a certain direction to be positive, and I will say the direction of the applied force, or the right, is going to be the positive direction. So I have a positive 5 newtons, and then I add that negative 3 newtons to that. So it's really positive 5 minus 3 newtons for my net force. So we get 5 newtons minus 3 newtons is equal to the mass, which is 2 kilograms, times the acceleration. Some of you in your head probably already knew that, oh, well, if I have 5 newtons to the right and 3 newtons to the left, the net force is 2 newtons to the right. So sometimes these are easy to do to find the net force. Sometimes they're a little bit more complicated, which is why I kind of gave you steps to find that net force. So we have a net force of 2 newtons to the right is equal to 2 kilograms, our mass, times acceleration. We divide both sides by 2 kilograms in order to solve for the acceleration, and we get 2 divided by 2, so our acceleration is 1 meter per second squared.